Okay, so basically, this lesson is going to be on linear equations, and we're going to start building a vocabulary, and from the vocabulary we'll be able to build concepts, and from the concepts we're going to be able to answer questions. So we're going to kind of go circular, clockwise, going like this, and we're going to start with a basic concept. And the most basic concept is both the x and the y axis. So this line right here in purple, or in pink, is the x-axis, and we're going to draw another line here. This is the y-axis. So this is the y-axis. Everything in this, like where this putty is supposed to go, is the y-axis, and everything in this purple line right here is the x-axis. Now, if you are here in the center of everything where the two axes meet, that is the point 0, 0. And every single point that you can plot on this chart is going to be described in this format. It's going to have an x and then a y coordinate. So here, where x is 0 and y, so if you go on this pink line, x is 0 here, and so is y. If you go up and down, y is 0 here too. So the starting point of this whole line right here, in the center of everything, is 0, 0. And this is a format that you're going to use for every single point that's listed in this graph. So we know that this line is actually described by the function, the linear function, y is equal to x. Which means that whenever you know y, if I know x, then I know y. So if I know x is equal to 3, Danny, what is y equal to?
3.
Right. What about if I know what y is? If I know y is equal to 9, what is x equal to?
9.
Right, because in order for this to be true, 3 has to equal 3, 9 has to equal 9, etc., etc. So that's what describes the values that fulfill this line, that make up this line. So every single point on this line has an exact duplicate value of x and y. So if it's 3, 3, that's a point on the line.
Yeah.
4.5 and 4.5, that's another point on the line. If I know all the points on a line, I can just basically use a ruler to draw a straight line to them. Sort of like this. So if I go like this, then I can use all those points and I can draw a straight line to them. Now this line that's described by all the points where x is equal to y is called a linear function. A linear function has different ingredients, right? Like a recipe has different ingredients. The ingredients that make up every single line are y is equal to mx plus b. This all looks very cryptic, and it doesn't make sense to most people because like, what is all these letters? I'm used to numbers. Why do I have to plug in numbers? Look, I'm going to basically take the letters and translate them into words, and then we're going to go from words into lines, and from lines into numbers. So we're going to go kind of around, same way we're going to go here. So m is equal to the slope. And the slope is a variable that's used to describe the rate of change. I'm going to rewrite it here because it's not a little blurry. So m is a variable that describes the rate of change. Danny, what does that mean? Do you have any clue? Nobody knows what that means. What this means in a much simpler way is rise over run. How many times do I have to go up in the y-axis to meet the same point on the line on the x-axis? So if I start here with 0, 0 and I go up to the third point, so 1, 2, 3, y is equal to 3 here, and x is equal to 3 here, 2, 3. So this point on the line, 3, 3, remember the x always goes first, think alphabetically, x in the alphabet goes before y. So if you don't remember if it's x or y first, think about the alphabet. So 1, 2, 3, that's the x point. 1, 2, 3, that's the y point, right? So if I go from 0, 0 to 3, 3, I have to go 1, 2, 3. So the rise is going to be the change in y over the change in x. Y changed plus 3, right? I went from 0 to 3, right?
Yeah.
So now it's going to be the change in y is 3. And what's the change in x? I went from 0, 0 to 1, 2, 3. Change in is 3, right? Is that a fraction I can reduce? 3 over 3?
No.
You can reduce 3/3? Can you reduce this?
No, because they're prime numbers.
But 3 goes into 3 one time.
Yeah, that's not. So I'm trying to make. You can actually do that. That's fine.
It's 3 times 1, 3 times 1, and you're going to cancel that out. You're left with just 1 over 1.
Fair enough.
So for this line,
Yeah.
where does this line cross the y-axis? This is the y-axis.
Uh-huh.
Where does it cross the y-axis?
0.
It crosses it right here, where y is equal to, so the y-axis, which is the letter B.
Yeah.
These letters and numbers are all very cryptic, but you have to understand the components of a line are all basic concepts. You can just look at a line, and then you can recreate the line. Okay, so the letter B is called the y-intercept. The y-intercept is the place where any given line intercepts the y-axis. This is the y-axis. This line intersects it at 0, right?
Mm-hmm.
So I can take this equation, which is y equals x, and I can put it in this format. Because I know that m is the slope and is equal to 1 over 1,
Mm-hmm.
which I can simplify it to 1, right?
Mm-hmm.
And the y-intercept, which is b, is equal to, where does it cross the
0.
0. So now if I just plug in there, y never changes. There's going to be a variable here. X never changes.
That's only variable there.
And there's going to be another variable here. We need to know what m and what b are equal to, and then we'll be able to write the equation that's represented by this line.
So it'll be
So we know that m is equal to 1, and we know that b is equal to.
0.
So then the real equation is y is equal to 1x plus 0. But isn't that the same thing as y is equal to x?
Yeah.
So this line, that is the most basic fundamental line of linear equations, one that we refer to a lot, y is equal to x, conforms to the format y equals mx plus b, right? But if all you do is try to remember y equals mx plus b, you're going to think, well, you're not going to remember. But if you think of m as the slope, you know, and the rate, how much does y change, over how much does x change, the rate of change, plus, you know, times x, plus, where does it intersect this line? This is the y-axis. Where does this line intersect? If you know even approximately where it intersects, you can actually find the best answer for your GED. If it intersects down here, any answer with y-intercept equals -3 is going to be the best answer. If I see 5 answers like this, y is equal to 5x minus 5, y is equal to 2x plus 5, y is equal to 3x. And I know that this line, if I see the picture of the line and I know that it's -5 down here, which one of those answers is correct? Even without knowing anything else.
1.
This is the answer. Move on to the next question. That's a test-taking strategy based on the fact that you know how to build the line and the components of it. If I just see a picture, I can tell you which answer it is. Now, the problem is going to be if I see that, oh shoot, now there's 2 answers with -5. Now I have to figure out what the slope is.
Yeah.
So based on whatever, once I figure out the slope, then I can figure out which one of these. But at least I have a 50-50 chance to get it right. And what I tell you, you're not being punished for taking a guess.
Yeah.
And the SAT, you do get punished. And the GED, you don't. So you know what? If you don't know and you're running out of time, there's 2 minutes left. Boom. Pick A or B. I don't care which one. But pick one. You have a 50-50 chance of getting it right. Okay? So, other thing that's interesting about lines is that typically you can be given points and you can use those points in a table format. Like this. If I know that x, like if we know that x is equal to y, then we know that 1 is equal to 1, right? So if x is equal to 3, y is equal to 3 for this equation, right? So I just basically show you that this line is the basic line,
Yeah.
right? And what's also important is like you're also going to be asked, what about when you know that like an equation like this, what does this mean? Now they threw a greater than sign in there.
Yeah.
So the greater than sign means that any values greater than this line, these are the values that they're talking about. If the equation is y less than x, we're talking about these values now.
Mm-hmm.
So understand the line is the equation. They're not talking about 3, 3. They're not talking about 4, 4. Those are the numbers on the line. They're talking about all numbers above, all numbers below. This is everything above. So if y is equal to, for example, if y is equal to 4 and x is equal to 3, that's correct, right?
Yeah.
That makes sense. This is true. So if I go here, 1, 2, 3, 4, 1, 2, 3, it's hard to see, but that point is going to be on top of the line. Every value above the line is going to conform to this, where x, this is the point 3, 4, where x is equal to 3 and y is equal to 4. Now if I want to do a point below, what about the point x is equal to 1 and y is equal to 1/2, right? Because y is less than 1. Like x is, so actually this is backwards. This should be, let's say 2 and this should be 3, right? Y is equal to 3. No, I'm messing up again. This should be this is 3 and this is 2. So if y is less than x, then 2 has to be less than 3. Is that true?
Yes.
Then it's going to land on this side of the line. So if I were to draw this again, x is equal to 3, 1, 2, 3, y is equal to 2, 1, 2. It's going to land right beneath the line that you're using to break it up. So this is also part of this. So you can use like almost common sense by just graphing something and seeing like how it graphs. Once you understand the way lines are formed, then you can actually graph them and use any figures that you're given to kind of deduce certain things about them. Again, what I'm teaching you is not just how to memorize formulas, but how to use your brain to kind of troubleshoot the problem so you can get the answer faster. You're not going to have time to do all these equations and all these things in most cases. You only have about, less than a minute to do each problem. So what I'm trying to teach you is the concepts so you understand them, but once you get to a test, you don't use the concepts, you use the troubleshooting, you use the critical thinking, you figure it out, you see if you can answer the question without even doing the problem. Because if you can spend 15 seconds on one and save those extra 30 seconds for another tough one, why not?
Sure.
Then you don't run out of time, you finish early, right? And that's the concept. Okay, so this is the thing with linear, where the exponent is always 1. So y is equal to mx plus b, and this is the exponent 1 and y1, right? Now, if you're going to be dealing with exponential, which you're going to be dealing when you get to college, I'm not going to go too much into detail with this, but what I'm going to do is, I'm just going to show you that this is the equation y is equal to x squared. It's shown by this graph right here. If x is equal to 1, you square that, 1 times 1 is what? 1. So that's going to be where x is equal to 1, y is equal to 1, that's this point. If x is equal to 2, what's 2 squared? 4. So this is 1, 2, 3, 4. That's this point. And so on and so on. This is called a parabola. That's an exponential function. I'm not going to go into you can actually do it for this one as well, where y is equal to x to the third power plus 5. I'm going to make it a little more complicated. So I'm going to build a table. Like for anything that I need to do an equation, I can always build a table, right? I'm going to use 1. So if I have 1 here, what is 1 to the third power?
1.
1 plus 5 more?
6.
Okay, 6. Okay, good. Now, if I want to, whenever I build a table, I always want to use a positive number, 0, and a negative number. Do you want to know why I use 0 for y? Because that's called the y-intercept. Then I can use that point to draw the graph. So I'm going to use 0 for this one. So if I do x, which is 0 to the third power is what?
0.
Plus
5.
equals?
5.
Okay, good. So now I said I did a positive, I did a 0, and I want to do, what's the third value I want to use? A negative, right? So now I want to do negative 2. So what's negative 2 to the third power, which is like this?
2, 4, 6.
2,
Negative
4,
6.
8.
8, yeah, negative 8.
Negative 8. Whenever the exponent is negative, an odd number, then, and it's a negative number, so in this case, here's 1 negative, 2 negatives. These two together are going to make a positive 4, right?
Yes.
Then I have to use the order of operation times negative 2. What's 4 times minus 2?
8, which comes to negative 8.
It's a minus 8. So every time you have odd exponents on a negative value, the product will be what? Positive or negative?
What's the name? Order of operation.
No, odd exponents on a negative value, the product will be, so if I have negative times negative times negative,
That'll be negative.
negative. If I have even exponents,
That'll be a positive.
no matter what, no matter what the value is, positive or negative, the product will always be what?
Positive.
So if I do minus 2, that's an even number, right? That's
Yeah.
going to be 4. Because every time you do two pairs, it turns into from a negative to a positive, right?
That's
So if this was to the 4th power,
that'll be positive.
these two turn positive, and these two turn positive, so then the whole product is going to be, so when you multiply a positive times a positive, you get
Positive.
positive. So whenever you have even exponents, no matter whether if they're positive or negative, they will result in a positive outcome. Okay? So this is the last one. So minus 2 to the 3rd power is minus 8, right?
Yeah.
So plus 5, what's minus 8 plus 5?
Minus
Which
2
one
plus
is
5
greater, the positive or the
negative.
negative? Okay, so the negative is greater in this case, right? So it's
Yeah.
going to have to be a negative, right?
Yeah.
Okay, so now what I'm going to do is I'm going to actually plot this second function on this line. Okay, I know the y-intercept
Yeah.
is what? Where x is equal to 0, the y crosses the axis at what? This is 0.
Uh-huh.
1, 2, 3,
4, 5.
3, 4, 5. So it's going to go here.
Uh-huh.
And that's going to be where the line is going to actually meet this axis, right? So this is one of the points in the line.
Yeah.
Now 1 and 6, here's 1 and here's 6.
Uh-huh.
One more, so that's going to be another point.
Uh-huh.
Negative 2, 1, 2,
Negative
minus
3.
3. 1, 2, 1. Sorry, 1, 2, 3. Minus 3. So it's going to be right here. So this line is actually going to look like this. Again, this is a story for another day, but this is what you're going to need to learn once you get into a higher level of mathematics. But in order to understand this, we have the same concepts. Y-intercept, we understand exponents, we understand order of operation. All the basic concepts are tools that you add on top of like Legos,
Yeah.
that you're building one on top of the other, okay? So this is exponential functions, which you're not going to deal too much with in GED, but it's important to know that the same skill that you're doing over there, you're going to be able to transform onto this. And when you're talking about these functions, this is calculus. This is college level math, which engineers need to use every single day to calculate, you know, how strong certain things have to be, like the force of something, you know. All this math is going to apply later.
Yeah.
If you want to be an engineer, you're going to need to understand calculus. You cannot graduate from college without understanding calculus. So even though this is a GED, and you have, you know, this concept is very simple, you just want a piece of paper. If you want to take that concept like a Lego and build on top of it, then you need to understand that perfectly so you can do this. And then this allows you to be an engineer, and then that lets you be an architect, then that lets you get the kind of life that you want. So this is a means to an end. Knowing this builds on this, takes you to the next level. Okay, so what I'm going to do next is I'm going to actually give you exercise to do. So I'm going to give you these 2 points on this line here, and I have 3 exercises. One is I want you to tell me what are the x and y coordinates for point A and point B. So I want you to put them here. Then I want you to find the slope, the letter M, for this line. And then I want you to draw the line, and I want you to give it to me in this format. But I don't want to see mx. I don't want to see mx. I want to see what value is going here. So I want you to rewrite this equation for this line here. So here.